This is this is the overview video for Milestone 1. This is your project worksheet slash outline. This is where you're going to do your work. All the information is contained in here. It's 15 pages. Not 15 pages of work, it's just 15, it's mostly pages of information on how to do the work. The work itself is relatively short. I walk through it, right? So there's basically 3 milestones to this project. Really 2, because the first milestone is just chemical formula. Second is Lewis structures. And then the third is you filling in details about them. So it's not a lot of work, but it's a lot of information. The reason why there's so much information, you guys don't show up to office hours. Less than 10 of you show up to office hours. So I've tried to put everything I can in here, condensed, to show you what you need to do. So 15 pages, 4 weeks of work. I don't know. I think that's pretty good. All right. So milestone 1, you're selecting your ionic molecule, your covalent molecule, and you're determining what the chemical formula is. You should have already watched the project overview video, the one that said watch first, the document that said that read first. If you haven't, get out of this video and go do that right now. Come back to this later. All right. There's step-by-step process. I use magnesium and chloride as the example. I walk you through identifying the cation and the anion. You should remember all that from quarter 3. If not, it might be hard, so you might want to jump out. It'll take you a little longer. You'll have to set up a one-on-one, and we can go over it together. All right. Remember, your cation is your metal, your anion is your non-metal. So it's going to walk you through figuring out the charge of each. So if I go to my periodic table just really quickly, right, you can figure it out by either counting up protons and electrons and figuring out the charge that way, or you can read the periodic table, which is our roadmap. So remember, first column, right? Hydrogen is a nonmetal. That's why it's yellow like these guys. It's in this column because it has 1 valence electron, just like these guys. Second column has 2 valence electrons. So these are cations. And so they're going to, by definition, lose electrons. They'll have more protons than electrons, which will give them an overall positive charge that corresponds to how many valence electrons they have, right? So if I lose 1 valence electron, I have 1 more proton than electron, gives me a +1 charge. If I lose 2 valence electrons, I have an overall +2 charge because I have 2 more protons than electrons. Stay away from transition metals. Don't try and form an ionic molecule with transition metals. Don't use this third column either. There's exceptions like borons in the third column, but it's a metalloid. Pick something in these first 2 columns as your cation. All right, ignore carbon, stick to nitrogen, oxygen, phosphor, sulfur, selenium, fluorine, chlorine, bromine, iodine. Forget these guys down here. These are your noble gases. They don't form molecules, okay? So pick something of these 5 or one of these 4 as your nonmetals. When you have anions, those are your nonmetals. They gain electrons. They gain however many electrons to get to a full shell, like a noble gas, right? So nitrogen has 5 valence electrons because it's in the 5th column. It wants to get to 8. 8 minus 5 is 3. It's going to gain 3 electrons, 3 more electrons than protons. Gives an overall -3 charge, right? Overall -2 charge because these guys have 6. Overall -1 charge because these guys have 7. All right, the outline walks you through this. Like I said, that's why it's long. So it gives you those ways of finding those things. And it gives you both ways, whether you're going to count them up or you're going to go by the column. Then, once you find out the charge of your cation or your anion, it's going to walk you through how to find your overall charge. So for my example that I did in this document, magnesium and chlorine, which you cannot use because it's the example, magnesium is in the 2nd column, so it ends up with a +2 charge. Chlorine is in column 7, so it gains 1 electron to get to 8 as overall negative charge of -1. So if you add those together, you have an overall +1 charge. Can't get to 0, so you have to add a 2nd chlorine atom. That means you have 2 negatively charged chlorines for a -2. Add that with your +2. That's how you get to 0. That's how you find your chemical formula. Okay. So you're going to go through and do that as part of milestone 1. Then you're going to do that for the covalent molecules. Covalent molecules are formed between nonmetals. when you get these, I've pre-selected some because they can get complicated and I don't want you guys to get lost. So you pick either hydrogen and fluorine, nitrogen and hydrogen, or oxygen and hydrogen. Okay, I used hydrogen and sulfur for my example, and I walk you through how to do it. It's very similar to ions, but these guys are not forming ions, right? They're covalent. They're sharing electrons so that each atom has 8 valence electrons to be stable like a noble gas, just like we talked about in class. And the exception is hydrogen, because hydrogen wants to be like helium, which has 2. Okay, so hydrogen just wants to get to 2 valence electrons. All right, so I walk you through that process. I talk about the octet rule, which is the term for why atoms want to have 8 electrons. They don't gain the electrons, they share them. Don't confuse terminology from ionic molecules and covalent. They're different. Okay, so you figure out the number of electrons needed to fill. You start with 8 and you subtract that by the number of valence electrons. Again, the exception is hydrogen, which just wants 2. That helps you figure out how many bonds the nonmetals are going to have, right? So if they're sharing electrons, you figure out how many bonds sulfur can have. If it has 6 valence electrons, then it can form 2 bonds, right? It wants to share electrons with 2 other atoms to get to 8. The document walks you through this entire process, okay? So you can see here, I show you with the valence electrons on hydrogen, 1 and 6. One hydrogen atom comes along and shares its electron with sulfur. That gives sulfur 7. It still can form one more bond. So then a second hydrogen atom comes along. And then when you count them up, you have 8. And then hydrogen has 2. It's the exception. Hydrogen is the only one that does that. All right, so it tells you how to write your chemical formula. You're going to fill in your formula, your symbol, and the number of valence electrons for each. That's all you have to do for milestone 1. If you are going through this document in this video and you're spinning your wheels, unless it's because you're really lost during quarter 3, then get in an office hour right away. All right. If you can follow this document, ideally you should be able to get this done in well under 2 hours. Okay. So remember, you should be through milestone 1 by the end of tomorrow. If you can't make my office hours for whatever reason, there's no excuse to not contact me. All right. Good job. And then there's another video for milestone 2 after this.